Hey, hello. Welcome to the Argonaut review of 2025. I'm Brett Marquardt, the project manager, and here we go. So just quick, for anyone who doesn't know, what is the Argonaut Project? We're an implementation community looking to advance FHIR and OAuth and healthcare exchange, looking to get data in the hands of providers, patients, and the whole community to make the best possible decisions to improve patients' lives. In terms of our membership, we have a strong group of technology vendors and provider organizations who provide input to our specifications throughout all of our projects. The most valuable thing they do is in terms of just piloting software with Connectathons, giving us their expertise, and then deploying to their customers. The whole goal of the Argonaut project is to get things out in the hands to change people's lives. So with that, here's a very quick view of a timeline, a high dollar timeline, we say. And now we're going to do a quick review of all the projects. And up first, we go fast here. So up first, we have FHIR Write notes.
Super. So this was a project that comes in a long succession of Argonaut projects trying to expand the scope of what we can write back into FHIR-based systems. And we've tried to be thoughtful about scoping each of these projects around a particular area that we think we can make meaningful progress in over the course of a year. And so this year we were focusing on allowing external applications outside of the EHR to be able to write clinical notes or other kinds of clinical documents back into the EHR and associate those with a patient record. This is building off work that we've started a little while back. And we've noticed that several vendors, including Argonaut participants, have some ways or some aspects of this capability that they support natively already. And so our best projects are sort of looking around at things that already work but don't work consistently and trying to figure out how can we get consensus on a common footprint so that third-party developers can write their software against that common footprint. So if you go forward one slide from here, Brett, each year when we pick out these projects, we try to figure out what will a successful outcome look like. We're not always perfectly able to predict, but we think about who we need around the table in order to get things done. And then we think about kind of what we're targeting. We knew that early on this year, we were going to be focusing on using the FHIR document reference resource and being able to point to documents that sat outside of FHIR, but whose metadata could be captured in FHIR. And we knew that there were different use cases for patient-facing apps as well as provider-facing apps. And we knew we'd have a lot of decisions to make in terms of the project scope, because this could be a very, very big area, depending on how we decided to tackle it. So one more slide to talk about what we did this year. So one thing that we did in terms of defining scope early on was we started to explore different places where EHRs allow clinical notes to be written. And there's obviously this huge frontier of ambient AI scribing technologies that have really exploded in popularity and usage across the last couple of years. And we learned a little bit. We talked to project participants who have deployed systems like this. But we decided pretty early on that we were not going to try to standardize ambient scribing APIs with this project. We were going to focus on something narrower, which was third-party apps that already have a note that needs to be submitted to the EHR, rather than the live dynamic process of recording and editing and streaming in sections of a note in real time. So we made that scope limitation pretty early on. And we also decided we weren't going to try to tackle what we might call full-on FHIR transactions, where I'm submitting a note to you, but maybe I'm also submitting a bunch of diagnoses and encounter resources and medications and bundling that whole thing up into a full transaction package. We decided we were going to focus on the note and just a little bit of supporting context for that note and submit that document kind of as one piece of information. So we'll talk through what we wound up putting in our specification and where it landed, but we also try to be really mindful of real-world implementability. So I want to highlight right up front that as we were working through the project last year, we wanted to make sure we could land a connectathon where we'd have multiple EHR systems and applications able to show that our draft spec was working, at least inside of their prototype environments. And I'm happy to say that we got to that point last fall. So in terms of what we wound up writing in the specification, all of this has landed in what we used to call it the futures page. Now we call it the looking ahead page of the US core specification. So we always think about where is going to be the home for a successful output. And so this write back capability builds on what we've been doing for a few years in US core, which is documenting information about how to write vital signs back into an EHR, at this point, writing notes as well. And we wound up defining two modes, which are very similar, but have some slightly different assumptions. One we call direct write, and this is an external system like a provider-facing app that's going to submit a note that just lands in the EHR. This typically happens because a provider has taken an explicit action and said, I want this information transferred from the outside app into my EHR. So that's the direct write pattern. The other is what we call a mediated submission, where a patient app might be creating a note or submitting a note into the EHR, but it might be in some kind of a holding area for a provider to review before it gets finalized and lands in the long term in the EHR. So the direct pattern and the mediated submission pattern, both useful for different kinds of use cases, but they all follow the same pattern in terms of the actual REST API interactions under the hood. It's just that the data are tagged differently to allow for those different workflows. We decided that we were going to focus on a very narrow set of MIME types for clinical notes. So, of course, the FHIR document reference points to its note content or embeds a binary object with the note itself. And we decided that to start, we were going to ensure that any compliant server would support text notes, so just plain text documents, as well as PDFs. And then we would add optional support for other types of notes that vendors could advertise as capabilities inside of their systems. And we know that PDFs can be quite large, and we wanted to set kind of a reasonable minimum size that servers would have to support. So what we landed on was a 5 megabyte attachment, so that if you're going to support this specification, that you could support bigger files, but you have to at least support 5 megabytes from a server perspective. And then we have a couple of pathways for servers that want to do more in order to be efficient in terms of being able to point to larger content. Always in these kinds of write-back projects, there's important questions of provenance. So how do you track where information came from and whether it changed along the way? And what we decided to do in this project was to give the submitting clients a fair amount of options in terms of how to describe the associated resources, like if a note is associated with an encounter or an author. Sometimes that author might be a provider in the health system where the note is being written. So that could be the case for a provider-facing app where the provider is just using this app to construct a note. But in other cases, an app might be helping to bring data from an outside system into your EHR. And in that case, the author of the note is somebody from that outside system. And so we decided to provide this flexibility so apps could share information, basically whatever they knew. And that could be just the name of the author, it could be a contained resource, or it could be a pointer to a provider inside the target system if the provider already exists in that target system. So we tried to be pretty pragmatic about that and to say that the receiving system should just be able to do what it wants with that information. If it wants to do a deep reference check and resolution, that's fine. If it wants to just render everything as a simple string saying this was the name of the author and boil everything down to a string, that's also fine. But generally, we try to think about provenance, what we call little p provenance, which is to say using existing properties on the FHIR resources, properties like author and date and context, to convey information about where this came from. We always have the option of falling back to what FHIR calls the capital P provenance resource if we need to be able to describe more and more explicitly. But as we've done in the last couple of these projects, we try to focus on really providing detailed implementation guidance for little p provenance. And we know we can go the big provenance route if we have specific use cases that need it. So that's just a little highlight of what went into the specification. And should I just go straight ahead, Brett, now to the other Write project that we tackled this year, which was a follow-up on work that we did in 2024. So in 2024, the Write project that we took on was focused on continuous glucose monitoring data. And as I said, we always try to figure out projects where we can make meaningful progress in a year. But sometimes meaningful progress does not mean going all the way from scoping out a project to having a published specification. In fact, that's very challenging, just given the way that HL7 timelines and deadlines work. So in 2024, we got all the way to the point of having what we call a community spec, or SEPC, as I might have typoed here in the subtitle here. But we had a community spec for CGM Writeback. And over the course of 2025, we worked with the HL7 Orders and Observations Workgroup to take that community specification and bring it through the HL7 ballot process through the Orders and Observations Workgroup as an official international or universal realm specification. So we put the ballot out, we resolved a set of ballot comments that we got from the community, made a set of refinements to that CGM specification, which were largely clarifications. We didn't change anything important about how the specification worked, but we provided more context about how it can be used alongside other HL7 standards. And we did a better job of documenting how these capabilities work and added a couple of capabilities along the way. One of the ballot comments that we got had to do with how an EHR system might be able to trigger or ask an outside glucose management system, hey, I've got an appointment coming up next Tuesday with this patient. Can you please send all the glucose data that you have about that patient so it's there and available ahead of the appointment? So we call that one-time submission ordering. And that was a capability that we hadn't originally built in. We'd sort of left it for experimentation, but based on ballot comments, we spec'd out briefly how that could work. So that spec was published September of 2025. It's available to view on the official HL7 FHIR publication site. And it really focuses on bringing continuous glucose monitoring data from outside platforms, which could be vendor-hosted platforms from companies like Abbott or Dexcom that make CGM monitors, or it could be from external glucose management platforms that bring data in from several devices and aggregate it around an individual. So we got through this, what we call balloting project 2025, and I think that wraps up the sequence of work on CGM.
Awesome. Thanks, Josh. And I realize we didn't do any introductions, so I'll try to do Josh quickly. Josh, clinician informaticist from Smart and Microsoft, obviously the inventor of Smart app launch and a variety of other things. And up next, we have Gino Canessa from Microsoft, who has been the subscriptions czar. And if you have questions about cross-version extensions, it's not Argonaut related, but gosh, man, he's been working very hard on that for R6. So please say thank you to him if you get a chance. So up next, Gino.
Yeah. All right. So this year, one of the projects we did was a subscriptions mini. As you can see here from the original pitch, we want to keep building on the project, taking our little bites of the apple, similar as we do in Write. And really, this is just driving the whole thing of server-driven workflows and things like that. In this case, focusing on the patient data feed stuff we have. Next slide, please. All right. So as we said, we needed some EMR vendors, EHR vendors to participate, some client infrastructure. It'd be great to have payers and public health. And the goal was to do some more refinement on the patient data feed and make sure that we had something that was actually implementable. We had a lot of theories, but hadn't had time to really put pen to paper and make sure that it actually builds and runs the way we want it to in the prior projects, so that we could make sure that what we're putting into US Core is the thing that we all think we can and should implement. And so we did. We worked on a Connectathon in February, and then we did another meeting sequence in April, 3 more meetings. I put the rough participation numbers. As always, we have the spreadsheets if people are really interested in details. But we had pretty good participation across the board. We had about 15 participants at the Connectathon, crossing about 10 companies or organizations. And then meetings, we had about 20 participants per across about 15 companies, orgs. Each meeting had fewer or more people, and some different organizations showed up to ones as they could. So overall, I think a very good representation and a good cross-section of all of the Argonaut participants and external collaborators in the space. So we did test it. We obviously kept it very tightly focused in the Connectathon and what we were actually doing. But everyone that was participating said, yeah, this is something that seems to work. There are some open questions, particularly around authorization authentication, some of which are projects that are pitched this coming year for 2026. Things like the cross-organizational access tokens or whatever the project pitch is now, and some of the organization-related hinting and things like that. All of those will play into that. There's also some questions about discovery that we want to talk about, which is really waiting on the application feature IG, which I've been assured is being published soon. Essentially, they're just waiting on fixing a couple things in publisher issues so that they can push that forward. So Overall, very happy with participation. Want to thank everyone who did show up and take the time to both mock up their solutions for testing and really had very good discussion around the different points. And yeah, I think overall, very good project and another step forward. And then, yeah, patient data feed in US Core.
Check it
You're
out
muted.
if you haven't already. Um,
Yes.
Thanks so much, Gino, and I look forward to future subscription projects. I think we still have a lot of opportunity to test the work.
Yep.
Uh, all right, up next we have Eric, the world's greatest FHIR IG editor, to talk about USCDI and US Core.
Okay, so we're this year we took on the USCDI version 6 design sprint, and this is a repeat of last year and year before that. We tend to do these every year that USC comes out. We are going to take up the challenge of taking what comes out in USCDI and turning it into the next version of requirements in US Core. So this year was USCDI 6, and it turns into, to give you the bottom line here, USCDI 6, we took the design information and created a new version of US Core, which is currently in ballot as US Core 9.00 ballot. Okay, next slide. Okay, so what is USCDI? In case you don't know, let me drop my slide here. So every year, ASCP puts out draft requirements and then finalizes them later in the year. This year, I can put this on the screen because it was a pretty small list. We have six different data elements that were added to USCDI version 6 from the previous year. And then based on industry feedback, we see the initial design for the next version of US Core, which is in a yearly cadence alongside of US CDI. And then we also, as another task or objective we have, is to provide some feedback to ASCP and ONC. And this is done sometimes earlier in the cycle and sometimes later in the cycle. When we work before it's drafted and finalized, we certainly have direct feedback. Sometimes we do have a host call, or I think we hosted a call earlier this year to look through it, and then we're able to give some feedback before the ASCP's designs became final in July. Okay, so our design goals here, and this is defined a minimum set of requirements for each of the data elements in USCDI, and those are typically converted into a US Core profile or element in an existing profile to meet both clinical use and our certification requirements. And then we want to do this to create minimum set of standards, and importantly, we want to allow for future standards development for specific use cases. We want US Core profiles to be reused, and so we want to create a floor of standards and then build upon those for more specific use cases. And also we want to leverage important work. So we see these new requirements come up. We look across the spectrum. We look even internationally, things like IPA, IPS, and then we look around the different work within the United States on these topics and try to come up with a initial proposal that we can discuss and bring to the HL7 community after we're done with our work. And the ultimate goal is to publish updated profiles in US Core for the next version. Next slide. Okay, so our solution here is that we get into industry participation, namely the Argonaut community comes together, comprised of HR vendors, health systems, other stakeholders, and then we review some proposals that we typically draft soon after the USCDI draft version is released in the spring. So we go out and do this kind of create, I would say, a set of strawman proposals based on the USCDI release in the spring. And then we bring those forward to the group. And after the final USCDI version 6 is published, because I mentioned we do provide feedback, and we have an early meeting before final to try to review some of these things. And then there's discuss it so that we can have some feedback back to ONC, or I guess we're called ASTP now, about some of the draft proposals. And so then after the final USCDI version 6 is published, which may or may not be the same as the draft, then we go and host a series of meetings in the summer. We started, I think, in end of July this year, went through August, and we hash out those strawman proposals and come up with something that we can present to the HL7 community at the September working group meeting. And then all the unfinished work is completed, everything's reviewed, and then we have unfinished work that we complete on HL7 sponsored calls in the fall. So we have a handoff that goes on. Argonaut picks up the early work, does the early design, then we hand it off to the HL7 community to finalize it, and then we get a publication in January of a ballot. That's currently in ballot, and everybody take your opportunity now to ballot on it, and then we'll go through reconciliation and publish a new version of US Core in a May, June cycle. So next slide, please. Okay, so the next step, so like I said, we're currently in ballot. Then the next steps for the USCDI design is to take those comments from ballot and reconcile them, and then publish US Core. And then we also always have a few topics that tend to be a little more controversial than others. And this was in several years in the past, we've taken some of those, I call them special topics, and we've actually hosted a little mini sprint or a series of discussion points around them in previous years. For example, I think we talked quite a bit about assessments, assessments and surveys and assessments, and then last year we had a little discussion about scopes. I'm sorry, I'm blanking, but we did every year. We tend to have one or two topics that we do discuss during the reconciliation period. And this year, I'm predicting, although my predictions don't always come true, that we have a PMO order design that may require a little refinement post ballot. So we'll see. We'll see what happens to that. And then we start beginning to plan for next year. If there's a USCDI version 7 that comes out, we'll start to cycle all over again, and then continue from there. Next slide, next slide. Okay. So, and Brett, do you have any other comments about the USCDI design sprints?
Yeah, I mean, I just remind folks the ballot's open through the end of January, so you have another week here to submit your comments. I know depending when you watch this movie, the video, but we will, this has been an annual project, so watch for, reach out, May, June to check in, or probably more like June, July to check in for USCDI V7 design. And up next, Eric's going to talk about granular controls, which is an add-on.
And one final thing I want to say about USCDI 6 versus USCDI 5, we did have a much earlier start last year. We actually presented and discussed this at the May working group and went through a lot of design. But this year we started a little later. And we did have, I think, one early meeting. Then we for folks to comment on the draft proposal. But this year we started later. So sometimes we start earlier, and sometimes we start later. Depends on a variety of external factors and what the data elements are that ASTP proposes.
That's a great point, Eric.
Okay, so our next project was a granular scopes update. And this was a mini project, and what we had added to US Core in version 7 was a requirement to support both resource and granular level scopes as defined in the 2.0 Smart App launch, and that complied with ASTP's granular scope requirements in HTA1. However, upon implementing that, it presented several challenges that were brought up, especially for the client app developer. And so the goal here was to help standardize and refine the use of granular scopes to help mitigate some of these challenges. So we held a series of calls. We can go to the next slide. A series of calls to kind of discuss a plan to help mitigate some of those challenges that I mentioned. The initial discussion led to a plan to catalog what scopes are being used by implementers, develop some best practice guidelines, and also as kind of an addendum to clearly document their strategy for adding new scopes to US Core. That was kind of unclear, so we wanted to clarify that as well. So, and then jumping forward to update our outcomes here, we did after surveying participants, most of the participants were basically using the scopes that were defined in US Core. So we kind of dropped the activity to catalog observation scopes because we found that was probably not needed. So sometimes in these projects we do kind of change gears a little bit, and that was one of the places where we felt that was unnecessary. So we focused more on focusing and drafting a set of best practices for developers on both the server and the app side, and also clarifying the strategy, our strategy in US Core for adding new scopes in the future. And so we did go ahead and draft some of these guidelines, and then the HL7 committee did approve adding this guidance to our US Core Smart and FHIR obligations and capabilities page alongside the scopes. And so we have much clearer, hopefully helps clarify some of the guidance for developers, app developers, especially so that some of these problems that were being faced will be mitigated in the future. And so as far as next steps on this, I think this project is mostly complete. We'll continue to track the issues related to US Core scope requirements and guidance, and we'll bring them up and maybe revisit them in the future. Oh, wow. I'm up again. Okay, so here's our US Core FHIR R4 to R6 transition strategy. So we're looking ahead. This is one of those look ahead type projects where we're trying to plan ahead and not try to play catch up. So we know that FHIR R6 is out there. It's currently in ballot right now. I think one of the normative ballots is starting off a series of ballots, and I don't know whether how many more ballots there will be, but it's currently in ballot right now. So we're looking forward to that. When that occurs, we want to be prepared with a set of guidelines and best practices in US Core, so we can kind of hit the ground running, if you will, starting our engines and getting going, using that analogy of the car. So we wanted to develop the initial design objectives were to develop a comprehensive plan to facilitate the migration to FHIR R6, and that strategy would include some things like best practices for implementing FHIR R6, some sort of timeline like a sunsetting period for R4, and clear approaches for managing these compatibility issues and minimizing disruptions. So we set up part and had a series of meetings this summer, and we'll go to the next slide. So we come up with an initial plan to define, right off the bat, we wanted to define the US Core's migration principles. So we wanted to identify some set of principles and that we would go forward with. And importantly, so we could all have a certain core set of expectations now as we anticipate moving to our FHIR R6. And then as part of that, we did identify some prior design decisions that needed review. Now, let's just say one of our principles is to not revisit all our prior design decisions, but there are a few caveats, and so we did identify those caveats. And then we went ahead and set about reviewing some of the changes between R4 and R6. And this was in the summer when it was R3 ballot was the latest and greatest. There may be a few changes now with the I'm sorry, not the R3. There was a ballot 3 version of R6 that went out in the summer. We used that. That was the latest. And now we have a ballot 4, I believe it is, version of R6. And there might be some changes there, but we did take a look at that. We summarized the major change patterns. So we were able to identify a set of patterns for major patterns in profiling. So this is all, at a technical level, what changed in the profiles. And so we were able to define a set of patterns and kind of scale them as level of difficulty, how hard to implement and impact, and whether they're breaking or not. We did identify some of the biggest breaking changes in certain profiles that US Core uses. And just to remind people, we did not look at all the changes in FHIR R4 to R6. We focused on the US Core profile. So that's a small subset, about 20 or so types that we looked at. Developed some tooling to help understand things. We've made a transform tool to take R4 examples to R6 examples, and that was helpful in looking at some of the challenges. And then we went ahead and prototyped the US Core FHIR R6 based IGN. I think it's based on version 6.1, and there's also one based on the latest version of US Core version 8. So we had a bunch of work on that area, and then we hosted a connectathon to test out some of our participants' ability to actually host FHIR R6 profiles for US Core. Okay, some of the outcomes we made this and developed these these principles for transition, and this was presented to the HL7 community and specifically the U.S. Realm Steering Committee. And so we had 5 major bullet points. And so, and I'll let you can look at those and read them at your leisure. So that was one of the major outcomes. It did also help us change the some of the documentation we do use in talking about the U.S. core and U.S. realm timeline. And so that one is in the next slide. You can see this has also resulted in some major changes here, not major, but updating this, not approved, but just kind of a looking ahead type of timeline. And Brett, you're the author of this, so I'm gonna let you take a stab at explaining this a little more clearly than I can, if that's okay.
Yeah, no problem. I mean, it's always dangerous to present a timeline in a video that you don't know when people will watch. It's January 12th, 2026. This is the news as of today. We had as a result of the Argonaut principles, the big one was, only a single release of US core per release of FHIR. So we originally had thought about an overlap model where like 2026 or 27 would have a US core on FHIR release 4 and release 6. The feedback from the Argonaut community and the US Home Steering Committee is that that's gonna be pretty challenging. And
Hmm.
so this is when we made a big shift. We don't know if 2027 is the year we do R6 or 2028. I think this may shift at the work group meeting. So there's a work group meeting end of January, and we'll revisit this and approve a timeline. So that may kick out another year. But that's the key kind of takeaway from here. And this matrix communicates a lot of things, right? It's which releases are on release 4, which version of US CDI, which version of US core. And then the colors were added here, which is a little tricky. I know not everyone we have KIRS and which version requires KIRS. And then on the bottom is what timeline that is required. So KIRS required 3.1.1 through the end of January 25. HTI 1 required R6.1.0. And of course, the HTI 2 proposals are 3, 4, we're up to 5 now. So we'll see when the next reset of the floor happens. But we'll, to track this particular slide, which I think does inform U.S. policy, the January U.S. Realm Steering Committee is the place to be. Thanks, Eric.
Yeah, and I think the bottom line here is this project actually moved this bottom line over 1 notch where there's no overlap. So that was a big shift. And I think that's one of the major outcomes of this early on in this project, and as well as the uh, other principles that we've established in. And I think it's important to note that um, in summary, we have I lost my train of thought. I'll just move on to hear this. The summary of we summarize the US 4 to R6 changes. That's a major thing. We developed a set of patterns to look for. And then we have also estimated some level of efforts for particular US core profiles as they go undergo that transition. We had a connectathon, and it was able to, and this is something I didn't mention before, but based on our discussions, we were able to identify and update some content in US Core where we have changes between version sections, and there was a couple sections there that we were able to successfully update based on some of the feedback. So that was all, I think, in all, a very successful project. Had some trepidation going into this project because it was a bit unclear what exactly we're going to tackle. We actually tackled quite a bit, and I think our next steps for this project would be maybe taking another stab at it and trying to clarify some of the approaches for managing compatibility and minimizing disruption. Looking at those special topics that I talked about, because we said we're not going to change our design decisions when we do the transition, except for a couple caveats we want to look at. We may not change it, but we haven't really taken a closer look at those. So that's one area where I think we could do some extra work. And of course, continue to prototype the US Core R6 resources based on now the latest version of R6. And again, I don't think there's going to be much change here. It's just making sure we tidy up the comparisons.
Awesome. Thank you so much, Eric. And it was a great project jumping into the unknown with some really nice outcomes there. So up next, we have Dan Gottlieb. He's more than bulk, he's the expert, some data quality, public health reporting, but he's going to play his role of Mr. Bulk here. Dan, over to you.
Great, thanks, Brett. So we did
3 Argonaut bulk projects this year, which is a lot. And so I'll go through them pretty quickly. So last in 2024, Argonaut did a project called Bulk Optimize, which was focused around adding some capabilities to bulk to be able to do more efficient exports for bulk export. And in this year, we took that work and standardized it through the HL7 ballot process, including publishing a new version of the IG and incorporating feedback from other folks in the HL7 community. And I want to give a shout out to Eric, who really helped with kind of managing the process and adapting to the formal implementation guide format. He's, as Brett said, the expert on IGs. So that was really helpful. So there were 3 capabilities in this bulk optimize effort that landed in version 3 of the bulk data IG. First is we formalized the work around the type filter parameter. So this was an experimental parameter in the version 1 and version 2 of bulk export, and was implemented in a bunch of different systems, but there were slight variations in how it was implemented, and we hadn't quite thought through kind of all of the interactions with search parameters. So we worked through a lot of that and formalized it in bulk as an optional parameter. So that kind of enables people to filter down the data being exported in cases where they don't necessarily want all of the data for the patients. And so that can be helpful in performance. Probably the main part of this project was around creating a mechanism to output data organized by patient. So you could get all of a patient's data together instead of splitting the FHIR resources across multiple files. This can kind of help some servers export the data more efficiently if their data is structured internally by patient, and also can help data recipients be able to process the data without having to load it into a server before and put it back together. So it can create efficiencies on both sides depending on the use case. And as part of that work, we also formalized a method of starting to return data before the full export is complete. So if you have some files that are generated and you want to return those to the bulk export client, you can do that now. And then we also added a way to page manifests so that you can have essentially infinitely large bulk exports. This isn't something that a lot of folks have run into from talking to them, but it's something that now we have a way to do that so that there isn't a theoretical limit. And then lastly, we did a little bit of work around creating FHIR groups using an API that's based on patient characteristics to support bulk export. And the idea there is, again, like if you don't need data on all patients in a system, being able to scope down those patients in a API-driven way rather than a UI-driven way could be helpful for reducing bulk exports. I will say I think this is maybe the least mature of the 3 elements here, and so we wanted to get it out there so folks can start really experimenting with it in systems. But I think this is one we may come back and refine in a future version. Next slide. We also did a new project this year. So there's a number of use cases where you have a FHIR bulk data set, and maybe that came out of a bulk export, or maybe it's a data set that's really well known, like a quality measure data set that you want to share with a third party. And right now, there isn't a standard way to do it. So folks are kind of developing their own approaches, which is great. But I think this was a real opportunity for Argonaut to come in and say, let's look across these use cases where people are creating different ways to do this and figure out if we can create a standard way to do it that would work well for many of these use cases. And so this is useful in cases where you might have a data set that you want to send to a regulatory agency. So HRSA in the US government created a way for health centers to submit data for quality calculation. And there's other kind of use cases where folks need to submit supporting data for quality measure calculation or the measures themselves, which could be very large. And so we wanted to be able to support that use case. Many FHIR servers and FHIR analytic tools need to be able to be handed large data sets. And so that's kind of another use case that kind of came out in some of this work. So we had about 30 meetings with about 70 participants. So really great participation from the Argonaut community and the larger FHIR community. We also had a virtual connectathon with 9 prototype implementations, and we standardized an approach where a data provider can send manifests to a server or can alert a server that there's data available, and the server can pull in that data, and then the client can check the status, or the data provider can check the status from the data recipient to see if there are import errors. And this is a key element because if you're sending data for quality measure calculation and the data recipient isn't able to import all that data, you probably want that feedback. And so we have a draft spec. I did want to make one comment here, which I forgot to mention at the beginning, which is we started out the project calling it bulk import and shifted to bulk submit kind of early in the project, because that really better encapsulates what's happening here. It's a data provider saying to a data recipient, I have some data that I am making available to you, but it's really up to the data recipient around whether that data gets imported into their system. So they might want to process the data without importing it. They might want to return an error. And so we didn't want this perception that it kind of enabled anybody to push data into someone else's system. So we renamed it to bulk submit from bulk import, but a lot of the current operations that do this are called bulk import. So just an important thing to keep in mind as we try to confuse everyone with naming. And next slide, Brett. So I won't go through the whole sequence diagram here. I think that I wanted to put it in the slides so folks who are interested can kind of dig in. I think the key point here is that from a data submission perspective, you're really sending a notification to the data recipient that I have data available, and then the data recipient can kind of pull it in asynchronously. And then the actual status information is transmitted through a bulk export. So the data provider goes to the data recipient and says, can you do a bulk export that gives me operation outcomes on the status of my submission? And they're able to retrieve that kind of regardless of whether there's one resource returned for every resource that's ingested, or whether it's kind of a couple operation outcomes that are returned for the whole job. So we wanted to be able to make sure that can scale. Next slide. And then we did, believe it or not, 1/3 bulk project this year. This is a mini project, so this was really just about 2 meetings. But a couple of years ago, Argonaut had proposed this idea of a bulk publish operation, which would formalize a pattern where you have some NDJSON data, you have some FHIR data in bulk, and you want to make it available to people. And Josh implemented a version of this in the Smart Scheduling Links project. But then no one really wanted to pick up the formalization. And that changed recently because bulk scheduling smart scheduling links is going to publication, hopefully in 2026 this year. And there's also interest from being able to use this approach for National Provider Directory in the US. So we wanted to take this concept, which folks are already using, and kind of formalize it and think through the details there. So in bulk publish, it's really basically a pretty simple operation where it's a location where a server can make available a bunch of NDJSON files with FHIR data. We reuse the manifest from bulk export there to make so that clients can have kind of a known structure to be able to walk this tree of this set of files. One of the neat things is because it's really about publishing information rather than letting the client query for specific data. It doesn't require a FHIR server implementation. Any kind of web server that can host files can host a bulk publish endpoint, which is really important. And then what we actually spent most of these meetings talking about was how you could support both really simple snapshot data that you're putting out there, as well as the ability for the data provider to incrementally update the data without forcing the data recipient or the client to re-download all the data. So we created a really lightweight approach to being able to add files to your manifest over time, and then at some point reset back into a snapshot of the data. And this is actually being tested later this week at the Smart Scheduling Links track in the FHIR Connectathon. So if you're interested in that aspect of it, or in the project more generally, that's a good place to go. Sorry, Brett, I jumped back to a little bit there. Next slide is another one I'm not going to review in too much detail, but I have the snapshot or the image on the left there. is just a standard bulk publish manifest that really mirrors, or sorry, that's the bulk publish manifest before incremental data is added, but it has the hints about how when the snapshot was taken and how often a client should check for updates. And then the one on the right has an additional file and some deleted information. So that kind of illustrates this really simple incremental update mechanism that's available. Of course, you can also skip all that and just create a very simple list of files. And so that's how some folks can use it as well. So we want it to cover the very simplest use case, but also have some flexibility there. Next slide. And so I talked about 3 different operations, and they all kind of target different use cases, but share as many components as we were able to do with bulk data. So I wanted to just very quickly kind of talk about how they relate to each other. So bulk export is the bulk operation that's currently published in the bulk data implementation guide, bulk data access implementation guide. And that's really focused on ad hoc type of exports. So the data recipient, the person pulling the data, has a specific data set that they want to retrieve and is able to specify that to the data provider and just pull down the data that's relevant there. And it's really focused on kind of a one-on-one transaction. So there's one data recipient pulling data from a data provider. In contrast, bulk submit is more of a push-based approach. So there, the data provider is saying, hey, I have a data set. And it's a predefined data set that you know what you were going to get. And then the data recipient can go back and pull in that data. And in contrast to bulk export, I think I mentioned this before, there's a feedback channel where the data recipient can kind of pull down status around how the data provider can pull down status on how the data recipient is processing the data. And then lastly, there's bulk publish, which we talked about. And I think the big difference there, that's also a pull-based approach, but in contrast to bulk export, it's a static data set, it's a predefined data set, I should say, and it's also more of a publication model. So it's really useful in a case where the data provider wants to share their data with a number of people. So I imagine something like a provider directory that's not updated that frequently, where you want to just make this data public to whoever needs it, or a formulary that a payer is providing to whoever needs to be able to look that up. So ways to provide large data sets to many people. And then in terms of next steps, I think probably the next step here, we have a couple open bulk submit design questions that came out of Connectathon that we're going to address next week in a meeting. But I think that kind of the big next step is really thinking about how we can combine these 3 different operations into a single implementation guide where we share information, we share components like the manifest format, and we have some guidance on which operation to use for different use cases. And so that's something that potentially the Argonaut Steering Committee will decide whether to take up in 2026 or kind of push off to the future. But it's the idea is that we should have clear guidance on kind of how these operations fit together and which one you would use in which use case. So it's a lot of bulk stuff, but hopefully that's helpful, and I think it'll be great if we can kind of take these more draft operations and kind of put them all into an IG together so that folks can really figure out what to use for a particular use case. So with that, I'll hand it back to you, Brett.
Awesome. Thanks, Dan. That was a lot of bulk. That's good. So Argonaut, we sometimes joke that we don't make the FHIR APIs you deploy, we make them better. In terms of how to participate, the best place to find us is on the Argonaut Confluence page or the Argonaut Zulip channel. And we're all happy to answer questions or point you in the right direction. So Happy New Year. When I think about the thank you for the collaboration, I think about the Argonaut members who've joined and written software to support these projects. I can't again emphasize how important the time you provide is. The money is important, but the time is more important. For the SMEs, Dan, Gino, Josh, Eric, thanks for your leadership. HL7 is the umbrella of which we are an Argonaut Accelerator underneath, and the services and support they provide. They're the premier community building organization in a health of flow and standards. So we're very thankful to them. And with that, We look forward to 2026. So keep your eyes and ears open. We're currently ranking new projects. We pitched 11 internally, and I think we'll have some sort of selection complete in early February and launching projects then. I look forward to everyone participating. So thanks, folks, and I hope you have a great 2026.